So whenever there will be randomization failure, at that time it will give you error. But if you have not written this assert, then what will happen? If there is any randomization failure, it will not give you any error. Simple simulation will get complete. You will not be able to know where is the error. So always write assert. Then this one, it is known as constant. Constant means I am giving the condition that you can randomize the values. Okay, but my write enable signal should be 1 and read signal should be 0. If I am not writing this, then write signal can be 1, can be 0, read signal can be 1, can be 0. But here I am saying that no, you make write signal 1, read signal 0. Okay. So now after generating those values, I am going to put those values inside the mailbox. Okay. So to put the values, use the put function. Okay. So here my object name is, mailbox name is M1. So M1 dot put tr. Now here what will happen? The generated packet is stored inside the mailbox. Okay. So whatever the values I have generated, I have stored it the mailbox. So how to use this mailbox? Okay. Mailbox name dot put. Put, it is one inbuilt signal. Okay. Now let you want to check what are the values generated. So tr dot display generator. You can check like this. Now end task. Okay, similar way I can write signals for the write also. Read. So here I have to make this signal 0 and this signal 1 generator. Okay. Let here I'm not giving these names. I'm simple generating the values. So here task run. This is my main task. Okay. So here I'm going to call this write task 10 times. Let 20 times. Then read 10 times. Okay. So this is approximately same as your Verilog code. Just this constant I have written. Okay. So understood about this generator class? See here what are the things I need to add. Here I have just generated only for one scenario. So I have to add, if I have more 4 to 5 scenario, how to generate those things, how to generate from the, how to pass those things from the test. So that things I will tell you one by one. Okay, first for the simple thing, you just know how to flow. Okay. Okay, so now here I have completed the generator part. Generator work is to generate the things. Now let you have 5 different scenarios. So you have to control from the top. From the top, you must be able to control when whether I need to generate signals for scenario 1, generate signals for scenario 2, generate signals for scenario 3. So you have to control from the top. So that thing I will tell later. Just for now, simple one test case, Flow will be from generator, generator to driver, driver to duty, duty to monitor, monitor to scoreboard. Then environment, test, top. So this will be my flow. Okay, so one by one, just for the simple case, let me explain. Okay, so understood about generator class, or I have any doubt for generator class?
No doubt.
So next we go to driver. So driver, this is one important. Okay, in the project, whenever you are writing the code, your most important, like code wise, that will be your scoreboard. Because in the scoreboard, whatever things you have done in the design, like designer have done inside the design, the whole thing you have to mimic inside the scoreboard or inside the reference logic. Okay, your scoreboard must be work like your design. So scoreboard, it is the complex one. Okay, and driver, its code is small. Like if you compare to scoreboard, it will be small, but it is important. Why? Because all the signals you need to drive from here. If here you are doing mistake, any mistake in driving the signals, then even if your design is correct, you will not get the correct output. So here it must be correct. You must be carefully drive all the signals. Let's go to driver. So class FIFO driver. So here also I am going to, so in the driver, what are the things I need to use? So what is the driver what? It will get data from generator. So here I need a mailbox. Next, it will mailbox and whatever the data that is in packet format, so the transactor class also. Next, it will drive those signals to duty through interface. Through interface means I need a virtual interface here. So these things I need to declare inside the driver. So FIFO transactor, asynchronous, okay, asynchronous FIFO interface. So FIFO transactor TR, then mailbox M1, then FIFO interface VIF. VIF means virtual interface. Okay. So again, virtual interface, same interface should be used by the driver and monitor. Same interface should be used by driver and monitor. So I am going to write it, pass it through the constructor. So function new, then mailbox M1. So it is the virtual, so I have to use the virtual keyword. Virtual FIFO interface VIF. So here first I will check whether mailbox is working properly or not. Okay. So repeat 30. Begin. TR equal to new. Then my mailbox name is M1. M1 dot get TR. And here I can write TR dot display See, here I am just checking whether I am able to get all those values or not. I have not written the logic to pass the signals to duty. So here, what is this get will do? It is a blocking method. Remember, blocking method. It will get values from mailbox. Blocking method means if you have not removed the first data, you will not be able to get the second data. There is another method, try get, non-blocking. Non-blocking means if second data is not removed, you can remove the third data. So what does this mean? This is one mailbox. From the mailbox at a time, two threads or two processes are taking the values. This is the mailbox. It is giving values to here, it will giving values to here. So here, let this one is working slow and this one is working speed. But here what will happen if you are using the blocking method, then after this will take the value, then it will take the values. Slow speed, it does not matter. Okay, it have to wait. After it takes the value, then it will take the values. So it is blocking. If you are using non-blocking, so whether it is taking the values or not, I don't care. Okay, it is the speed. Okay, this is the slow. So whether it is taking values or not, I don't care. I will be able to take the values whenever I need. So that is non-blocking method. So depending on your requirement, you can use blocking as well as non-blocking method. Okay, so now I just have to check whether I am getting the values properly or not. My mailbox is working properly or not. Okay, so here, take include transactor.sc. I have to declare all the signals here, sorry, all the files, because it will not get included automatically. Generator. See here the sequence should be same. What should be the sequence? I am going to use transactor inside the generator inside the driver. So transactor class should be declared first. If it is not declared first means whenever I am declaring this generator class, it will search for transactor in the above and it will not get the transactor class, it will give you error. So here FIFO generator, FIFO driver. So FIFO generator, FIFO driver. So here I have to declare one mailbox also. Mailbox M1 and this interface also. So FIFO INTA. So here I don't have to write it as a virtual. Why? Because my top I have written inside a module. Module means it is a static component. So here I need to pass the reset signal, clock write, clock. Okay. So this clock write, clock read, I can write it as bit reset. Right. I am not going to generate all those signals now because I just need to check whether generator is my mailbox is working properly or not. So generator is equal to new. So here I have to pass the mailbox as an argument. Then drive equal to new. Here I have to pass the mailbox as well as the interface. Here it should be a virtual interface. So, okay. So M1 is equal to new means here I am creating memory for the mailbox. So in the mailbox, what are the functions you can use? New, put, get, try get. So I'm going to call all the run functions. Here it will generate the values. From the driver, it will drive the values. Transaction class 19. So here it is showing me error, unexpected token. So maybe my error is in some other class and it is showing me here. So I'm just commenting this to check whether all the 4 files have any error or not. Okay, so 2 error, class and class. Where the interface. Okay, here I have not written end class. It's better to write one class then compare the error. Sorry, then compile it and check the error. Generator. Generator 27, 28. Sorry. This will be repeat 20 right. I want to call the right signal 20 times. So repeat 20 right. Repeat 10. Okay. So no error is there. Now I can remove it and check. Some fatal error, generator SB mailbox reference is null. Okay. Okay, so first I have to create the memory for the mailbox, then only I can use the mailbox. So now you can see in the generator, values are generated. First, my data in equal to E2. Write enable is equal to 1. See, full X overflow is equal to X means these signals I should get from the duty. But I have not connected my test bench to duty. So I will be getting these signals as X, not a problem. But this signal first is E2, right, equal to 1. So we will check in the driver what is the first signal I am getting. So driver first signal is A2. For driver second signal, I am getting A9. So generator also second signal is A9. Okay. So my mailbox is working fine, right? Understood about this mailbox?
Yes, ma'am.
Okay. So now we will check. Okay. So this test part I will be tell this in the tomorrow class. Okay. Because here it will be more complicated. What I have to do? Okay. So let me write here in the driver. So first I will declare one mode port and one clocking block inside the interface. So now with respect to write clock, I have to drive the write signals and with respect to read clock, I have to drive the read related signals. These two things I have to do. So tomorrow I will tell how to write the mode port, clocking block and the driver part. Okay. So up to this, you just here the important is mailbox. Just go through the theory of the mailbox. Okay. Here, whatever the things I have explained today. Okay. Here I have written the mailbox theory. Just go through the mailbox. Okay. Here the code I have given. Assertions, no need to go right now assertion. Whenever I'll be explaining the assertion and coverage, you can go through it. Okay. And again, go through this clocking block. This part. Okay. So tomorrow I will be explaining you the driver plus monitor, these two parts. Driver and monitor somehow they are similar because whatever the operation driver doing packet to pin level, monitor will be doing pin level to packet. So the signals like whatever driver operation exact opposite will be monitor. Process will be approximately same. So these two things I will be explaining tomorrow at 8 p.m. Okay. Hello.
Yes, ma'am.
Okay. So if you have any doubt or I should stop the class. Let me know. Okay. If you have any doubt from any other topics also, I'll be explaining. Like if from Verilog or the SystemVerilog parts that I have completed.
Ma'am, can you just once explain that full and empty logic once that FIFO?
Okay. Full and empty logic.
Coding part, ma'am, only.
Okay. That part I told you to explain. Yeah. So in the binary, I guess you have understood. In the gray pointer, you are facing the error problems, right? So
Yes,
if I'm using the binary counter, then it will be like MSB for read operation. My read pointer equal to write pointer. Okay. For so not for read, it is for empty. For full condition, my read pointer MSB should not be same equal to write pointer MSB. But all the others part of read pointer rest signals should be equal to write pointer rest signals. Here mean not equal to means here one time write address wrapping has happened. Okay, address wrapping means address not same. Okay, so write pointer read pointer rest part same means it is a full condition. Same thing if I am going to implement in the gray counter. Then for the empty, your read pointer equal to write pointer conditions will be same. If I am going for full, then read pointer MSB not equal to write pointer MSB plus read pointer, like for the binary I am just checking MSB 1 bit, but for the gray counter I'll be checking 2 MSB bit, last 2 MSB bit. Okay, read pointer MSB minus 1 not equal to write pointer MSB minus 1 and rest parts